Hello again. So today we're going to solve this question 18. This is a complex, unfamiliar question for complex number system. It's involved with Moivre's theorem, as well as the argument of complex number. So we know argument is the theta, the angle. When you convert from a Cartesian to Cartesian form to the CIS form, which is using the angle. So now we're going to solve this particular question. So this is given the equation, pretty long. Look like pretty long equation. So we have another two complex number. One is W1, the other one's W2. So we got W1 is the solution with the maximum possible. W1 is another complex number, but the solution for the maximum possible value for the real component of the Z. So that means the W1 is another complex number, is the solution of the real component of Z to be maximum. And W2 is the solution of the imaginary component of a Z to be maximum. So we got two new complex numbers. Now we need a proof. Show means to prove. Z to the power of negative to the power 4 divided by Z W2 belongs to integer set. So we need to prove its division is integer. So, okay, let's do that. So let's simplify this equation on the left-hand side. So you can see when I do left-hand side of the equation, I expand in the brackets. So you can see when I expand in brackets, you'll see the order. So top will become 15, 14, 13, 12, and to the last one becomes Z to the power 2. Now, you can see that's a negative. Then I'll expand in the next one. Same thing, same order, and I'll line up together with, you can see one negative, one positive. The other one is, so I'll put a plus here. So one positive, one negative, that's a positive, negative, negative, positive, positive. So you can see all cancel from second term onwards, the negative 14, Z to the negative 14 and cancel with positive 14. And Q, you will cancel all of them. So leave the last term with Z plus Z to the power 15 minus Z. So the right-hand side is 1 minus Z. So therefore, you solve this simple equation. So we got Z to the power 15 is 1. So we know Z to the power 15 is 1. So the magnitude of that Z is 1. So therefore, we can let the Z become CIS. So we don't have R is 1. So equal to cis theta. So theta is the argument. So therefore, we can solve for this equation, cis 15 theta equal to 1. Let's find a theta. So theta is, now because of the cosine, so this equates to cosine 15 theta plus I sine 15 theta equal to 1. So we can solve for that one. So you can see cosine 15 theta equal to 1. So the 15 theta must be 2 times by m pi, because n is an integer. So it's got unlimited solutions. So the theta is 2n pi divided by 15. So now we can find that the argument is the 2n pi divided by 15. So we put a z is a CIS, 2 on n pi 15. So n is the integer. But now we're going to decide what is the maximum real component. So we need to decide n. Now we have a condition say because the argument is only we need it from 0 to pi. So but that's actually from first quadrant to the second quadrants. So the real component of z to be maximum. So this is the real component of the z to be max. So that means the argument must be approached to 0 because cosine 0 is maximum. So therefore the n cannot be 0 because if n equal to 0, which is exactly equal to 0, because you can't equal to 0. If you look at the argument is greater than 0, less than pi. So we have to choose the second closest integer, which is n equal to 1. So therefore, we can see the maximum to be maximum. We choose the next. The argument is 2 pi over 15. So we said solution for W1 is CIS 2 pi over 15. So that's my argument. So to be cosine to be maximum. The imaginary part of z, which is sine 2n pi divided by 15 to be max. So that means the sine to be max means this argument must be close to pi over 2, but not equal. So that means you're closest to 15 over 4. So therefore, 15 over 4 is about 3 3¼ So therefore, the next n, the integer should be n equal to 4. So the angle has to be 2 times 4 pi divided by 15, which is 8 pi over 15. So therefore, the W2 is CIS 8 pi divided by 15. So now we do the division. So W1 to the power 4, we know this is using the Moivre. So 4 times by 2 pi over 15 divided by CIS 8 pi divided by 15. So you can see those two exactly the same. So it becomes CIS 0, CI 0 is 1. So therefore, it belongs to integer. So we proved QED. So this is a quite interesting question, and it's not easy because you're going to expand in brackets as well as define the angle for W1 and W2 so that you can use de Moivre. This is the de Moivre theorem to find the final answer. It's a great question, so hope you like it, and if you do, please give us the thumbs up and also subscribe to the channel for more videos later on. Thank you for watching again, and I'll see you next time.